Hi, today we're going to work on a nifty little integral. Here it is. We want to evaluate the integral from 0 to 1 of sine squared of ln of x dx. Now, there's an issue right off the bat. On this integral from 0 to 1, ln of x is not defined at 0. Ln of 0 approaches negative infinity, so it's undefined. So we'll have to find a way to evade that. So first, let's take note of that. Okay, so how will we evade this discontinuity? Well, first, for reference, let's call this integral I. And then having done that, to get around this problem of 0, let's write that I equals the limit as epsilon approaches 0 from the right of the integral from epsilon to 1 of this integrand. So from 0 to 1, as we come towards 0 from the right, not quite getting there, we'll evade that discontinuity and not tend down to negative infinity. Okay, good. So we've got this. Now, right here, we're working with a trig function to the power 2. Let's bring that power down a step. Note that we have sine squared of theta can be written as 1 minus cos of 2 theta all divided by 2. Just a simple trig identity. And if we make use of that identity, we now have that our integral I is the limit as epsilon approaches 0 from the right of the integral from epsilon to 1 of, okay, well, our argument here is ln of x, that's our theta. So we can write 1 minus cos of 2 times theta, which is ln of x, and this is all divided by 2 dx. Now we can pull out that factor of a half here in the integrand. So we'll swing it out here in front of our limit, leaving us with the integral from epsilon to 1 of 1 minus cos of 2 ln of x dx. Well, we can split this up into two integrals. So the way we'll do that is write I equals half the limit as epsilon approaches 0 from the right of, okay, well now, with this term, we have the integral from epsilon to 1 of 1 dx minus the integral from epsilon to 1 of cos of 2 ln of x dx. So from here, we have two integrals to evaluate. We have this one over here. Let's call this I1 in green. Then we have this one over here. Let's call this I2 in orange. Now I1 is easy to evaluate. Let's go up here. So I1 is this integral, which is nothing more than, well, we're integrating dx. That just gives us x evaluated from epsilon to 1. And so substituting 1 in, we get 1. Substituting epsilon in, we get minus epsilon. So there's I1. Now for I2, here's the following. We'll work this out through integration by parts. So we'll let u equal what we see here, cos of 2 ln of x. And if that's u, that implies that du is times the derivative of the inside use chain rule, so 2 times the derivative of ln of x, that's 2 times 1 over x, dx. And then we'll let dv be what we have remaining, so dx. So this implies that v is equal to x. Okay, great. So the I2 then is nothing but uv evaluated from epsilon to 1 minus the integral from epsilon to 1 of v du. So we have this times all of this. When we multiply this and this, we have an x up here and down here canceling out. And that's okay because we're not including 0 in our bounds. We're only approaching 0 from the right. So we're left with 2 times, that'll be pulled out, this negative sine of 2 ln of x dx. But now we're going to use integration by parts one more time on this integral right here. So we'll call this I3. So for I3, we'll let, same idea as up here, we'll let u equal sine of 2 ln of x. And then that implies, when we differentiate, that du equals, well, the derivative of sine is cosine. Keep the argument. But by chain rule, multiply by the derivative of the inside. So 2 times 1 over x. And then we'll let dv equal what's remaining here, dx. So that tells us that v equals x. Okay, good. So I3 then is simply uv evaluated from epsilon to 1 minus the integral from epsilon to 1 of v du. So that would be x times this quantity here. Again, this x and the x down here will cancel. This 2 up here can be pulled out front. So we're left with cos of 2 ln of x dx. But if we notice, this integral, where have we seen that before? Well, that's just right back here. That's I2. So what does this tell us then? We can write I2 equals this plus 2 times all of I3. And so to make a little bit of room, we'll remove this. And we'll just make note down here that that's equal to 1 minus epsilon. So I2 is simply x times cos of 2 ln of x evaluated from epsilon to 1 plus 2 times I3. Now I3 is all of this, but we'll put what's in blue and call it I2. So x times sine of 2 times ln of x, evaluated from epsilon to 1, minus 2 times I2. Having done that, we have I2 equals x cos 2 times ln of x, evaluated from epsilon to 1, plus, now we'll distribute this 2 here. So it's 2x sine of 2 ln of x evaluated from epsilon to 1. And then distribute the 2 here, that's minus 4i2. But what we can do is take this minus 4i2, add it to this one. So we have 5i2 equals this plus this. Okay, great. But what's I2? We can divide through by 5. And there we have it. Now we can go back and say that I is the following. Half the limit as epsilon goes towards 0 from the right of all of this. In green we have 1 minus epsilon minus I2 here in orange. Well, now that's this quantity right here. So let's go to the next board and finish this up. Okay, so here we are now. We left off with I equals half the limit as epsilon approaches 0 from the right of our integral in green, I1, minus our integral in orange, I2. So let's evaluate our I2, what's in orange, from epsilon to 1. So we obtain the following. We'll leave what we have in green, minus, in orange, evaluating at 1, we'll plug in 1 here. Minus what we have when we plug in epsilon. Okay, so we have that, plus evaluating this from epsilon to 1. So plugging in 1, evaluating at 1, we have that, minus plugging in epsilon. Okay, good. Well, now let's take a close look. Here, ln of 1 is 0, and same over here. However, cos of 0, this is just 1. And here, sine of 0, that's 0. Okay, so what does this all boil down to? We have I equals half the limit as epsilon approaches 0 from the right of 1 minus epsilon minus this orange piece here. So that's 1/5 times 1, so 1/5, minus minus plus epsilon over 5 cos of 2 ln of epsilon plus 0 minus distribute, so it's plus 2 epsilon over 5 times sine of 2 ln of epsilon. Okay, good. Now when we evaluate epsilon at 0, in this next step, we have half of 1 minus, okay, epsilon goes to 0, minus 1/5 plus, well, epsilon goes to 0. So that just means this entire quantity is 0. Plus, here as well, when epsilon goes to 0, we go to 0 here as well. So all we really have now is 1 minus 0 minus 1/5. So we have half of that. 1 minus A fifth is 4/5. But that just simplifies to 4/10, which also just simplifies to 2/5. And so there we have it then. This integral from 0 to 1 of sine squared of ln of x is simply 2/5. Thanks for watching.